Good morning, everyone, and welcome to the session. So my name is Shashi, and in next 35 minutes or so, we'll be talking about XCUITest and best practices, or at least my experience of using XCUITest over 3 years or more than 3 years. So little bit about me. My name is Shashi, and my background is basically from mobile DevOps, setting up CI/CD pipeline, and writing test automation for native apps. So I have done most of the stuff for iOS and a little bit for Android. So my tooling involved XCUITest, XCTEST, Swift, and lots of developer tools provided by Apple. And using that developer tools, write a script so that your CI/CD pipeline looks smoother. I do write an active blog about iOS continuous delivery, and my blog is known as XCblog. There's my Twitter handle at the bottom. If you feel anything about the talk, feel free to tweet at me during the talk or after the talk. So this is the agenda for today's talk. So we will talk about current state of iOS app testing. Then we will talk a little bit about XCUITest, and we will talk about the test design pattern, how you can design your XCUITest, and some tips and tricks how you can improve your XCUITest to be DevOps friendly or CI/CD friendly. So I hope most of you have mobile apps, right? That's probably the reason you came to this talk. And the mobile app development or mobile testing is kind of depends on how much revenue your company earns from mobile apps. I saw some companies earn more than 50% of their revenues from just mobile apps, and out of that 50%, most of them coming from iOS app. There are Android, but compared to iOS, the Android is probably very lesser. So iOS is a secure operating system, and you can see that most of the people use because, or most of the banks use because there's security of Apple platform. So the way currently most of you or the companies which don't use native tools does automation for iOS app like this way. So we have a heavy manual testing at the end of the release. So you probably have a long spreadsheet that you probably run after end of every release. Then after some time, you find out that's not an efficient approach. We need to automate some tests in order to save time, save the duplication of the boring manual testing. Then we came across the market and see what are the options available. So you search it on Google or something, you find, oh, there's Appium, there's a Calabash, and you made a decision straight away. Okay, Appium is used by everyone. Let's start using it. And then you start automating your tests using Appium. Obviously, Appium gives you ability to run tests both on iOS and Android. And then you start automating your test inside the simulator, all the user journeys. And you spend a lot of money hiring test automation engineers or maybe some consultant, and you get up and running. So what happens after that usually is you will get the flaky automation, the test fails randomly, and if you go and ask the question for the guy, iOS developer or Android developer, say, what UI testing framework do you use in your app? The answer would be probably, I don't know, that's something QA team does. I didn't even look at that yet. And this is the case for iOS for most of the reason, because the guys who develop the apps use Swift or Objective-C, and the QA team who writes the test in Appium or Calabash or any third-party tool, they use Java, .NET, Python, Ruby, whatever language of their choice. And what happens then is it creates a huge technology gap between developers and QA. Say they don't understand their language, and they don't want to contribute back to each other's tooling because the technology stack is completely different. And this is kind of anti-agile, or you can't have that CI/CD pipeline working well because you have to pull the developer's code, and then once the app is built, then you have to pull the tester's code in the CI/CD pipeline and then run your test. And if you're adding more complexity, more third-party framework, then the CI/CD pipeline become kind of a pain. Let's not jump to the conclusion. Let's change the gear and talk about what is XCUITest. XCUITest, also known as Xcode UI Testing, which is a framework launched by Apple in 2015 to solve the user interface testing problem so that we can write a test where like a real user does. So you can basically tap on the UI element, navigate to the app as like a real user does. And it's designed to be write the test in the same source code where your application source code lives. So you can't have a separate repository for writing test. You have to write your test inside your app's code. What it brings is like a collaboration. If someone wants to contribute to your code base, then you have to have like a solid test or solid code going into your app's code. Although it's a test code, it is a code. XCUITest is based on the accessibility technology. What it means is like, if you want to use XCUI, then you need to have accessibility identifiers. So whenever you declare any UI element in your app, you have to make it mandatory to have an accessibility identifier. Without accessibility identifier, XCUITest is useless. So it is very important to keep in mind that you should have accessibility identifier as a mandatory check for while developing your apps. You have to have a strong rule with your team, your development team, that you can't have any UI element without accessibility identifiers. Otherwise, your test will be so flaky. And one of the problems that other tools, third-party tools like Appium, allows you to have workaround, like find element by ID or XPath or that kind of stuff, which add more flakiness towards your test. And the last thing about XCUITest is it's a black box. What it means is like XCUITest is designed to be used as a real user. So your users doesn't have access to your data or your APIs of your app. The same way XCUITest doesn't have access to your app or API. So you can't have a direct connection from your app into XCUITest. You need to have a separate setting in order to communicate with your app. XCUITest runs in a separate process. So you need to, whenever you're using XCUITest, you will find there's another app called Test Runner installed in your simulator or devices. So Test Runner app talks to your main app using accessibility API, and then it sends the event to tap on a specific element or do some action on your screen. So that is XCUITest. But the biggest challenge comes how do you learn XCUI test? It's interesting because Apple has so many videos in their WWDC conferences related to testing. And they have a official documentation on UI testing as well. However, these resources are not like kind of end-to-end. So if someone wants to get started from scratch, these resources are not structured in that way. So luckily, last week, we announced Test Automation University course on XCUI test. It's a shameless promotion that is done by me, but this course is structured anyone who want to start it from scratch. So I would recommend you to check this course and see how you can use XCUI test from 0 to getting your test all the way up to the CI. Next thing, when you start writing XCUI test, one of the things you probably start looking into, like when you grow your test suite, then you probably want to refactor your test code. So Selenium World has provided the method of page object pattern or Screenplay pattern. So we tend to adopt this pattern and create a page object model or Screenplay pattern, and then we abstract our UI elements into that classes, and then we use that into our test. But with XCUI test, it works, but this is not the nature how the Swift is designed. So Swift is object-oriented language, not object-oriented language. It's kind of protocol-oriented language. What it means, it supports object orientation. You can still have inheritance and features, but the ultimate goal of Swift is to write a protocol in first place rather than writing the classes. If you want to know more about what is protocol-oriented programming, you should visit this linked talk, which explains all the questions or all the things you have probably in mind. That video answers all your questions about protocol-oriented programming. So why not we use those protocol-oriented features of Swift in our test design pattern? So this is kind of a login test, a simple login test. So if you want to use page object pattern or something, you probably create a class. But you can easily define a protocol in a Swift, what you wanted to test. And then you write a thing called Swift extension so that you can implement your step definitions. And then you can use Swift enumeration, where you can store your UI element. So in Swift enumeration, you can store all UI element. In there, you can dynamically access the elements for iPhone and iPad. So you don't have to write a separate test suite for iPhone and iPad. So the course on Test Automation University has explained how to set up the protocol-oriented structure using this Swift protocol extensions and enum. So we don't go into detail in this talk. So having that framework in your app, what we get is scalable steps. That means once you wrote the step, you have access to that step all over your UI test target. That means you don't need to instantiate any class, or you don't have to do any kind of crazy inheritance stuff. And as I said earlier, your test suite will run smoothly on iPhone and iPad, so you don't have to write separate test suite for iPhone and iPad. And we will get the human readable and reusable steps with nice reports. So there's a thing called XCT activity, where you can define your string in English language, and that string is reflected into your Xcode reports, which means your reports become like a plain English. So you can show it to any non-technical people saying, okay, this is our test we run. You don't have to mention any technical details in that XCT activity. And as XCUITest can be run using command line tools called Xcode Build. So it's same like a unit test. So you can easily plug it into your CI pipeline. So you don't need to build separate app or separate app structure for your XCUI test. It just build the main app and start running your existing test. While in Appium world, you have to create your app binary before you run the test, and then the Appium will pass that app and run the test, deploy it into the simulator or devices and run the test. We don't have to do that with XCUITest. Now let's talk about some tips and tricks, or you can call the lesson that I have learned using XCUITest for more than 3 years. So XCTest is a framework for writing unit test, integration test, or API test. It's kind of lower level test framework by Apple. And XCUITest is extension to XCTest, where you can write user interface test. So it would be a good idea to use XCTest for all levels of testing, and do not introduce any sort of additional tool for, like, for example, API testing tools or performance testing tool. So you might see that there's tools available for API testing. You might want to use that for API testing, or some tools for performance testing, like a JMeter, Gatling. That's okay for your testing backend API. But what about front-end? Front-end performance testing, as you have probably heard in keynote, Charles mentioned that front-end performance testing is a key. And luckily, XCTest framework allows you to write performance test, front-end performance test for your iOS app, straight using XCUITest. Another thing, if you want to use XCUITest, you have to be very strict about accessibility identifier. You shouldn't be allowing your pull request to be merged without accessibility identifier for UI element. Otherwise, you will get a flaky tests. Another thing is, by default, Xcode creates the debug and release configuration for your iOS app. And when we run the test, we're likely to use the debug configuration, but we can create a separate configuration, for example, test configuration for testing our app. So creating the separate configuration help us to not to leak any test code into the production, or do not want to pollute debug configuration that can be used for different purposes. So real device testing is one of the questions that I usually get from many people. So when you write XCUITest, how do you execute your XCUITest? Do you use simulator, or do you use real devices? So you need to be very careful about what is your app doing, and you need to understand what's the feature that simulator is giving you, and what's the feature that real devices are giving you. So basically, simulator is a software interface which doesn't have any hardware interface, but they can do all the job for you. And if your app has a hardware interface, you can't avoid the real device testing. Also, in my experience, I haven't found any issue with XCUITest that is not working on simulator, and that's working on device, or vice versa. So basically doing the same thing, but you need to identify what are your applications requirement, what are your applications hardware requirement. And if possible, keep your limited set of UI tests run on real devices, and you can use all the simulator features provided by Apple to run most of your UI tests. Another things, I saw many companies, they're writing loads of UI tests. I saw companies writing about 500 UI tests. And in my opinion, that's not the right approach. You should cover most of your stuff using contract testing, API testing, and all other lower level testing so that you just remove the burden on UI test. So UI test, you can just categorize only for your key user journey and key business feature. And all other business logic you can get covered by contract test, API test. The API test, we can simulate almost all the user journeys. But in UI tests, what we need to check is your button works, your application just go through like your real user does. So for example, if you write your API test, which passes because you make a backend API call, you get a response. But what if your button is disabled on the app? So UI testing is still important. You can't avoid the UI testing because UI testing checks your application works. And as I said earlier, for front-end performance testing or client-side performance testing. So XCTEST framework, when you write performance tests with XCTEST, it runs the test 10 times and create a baseline. And once the baseline is created, then you can set it as a baseline, and next test you run against that baseline. So for example, if you set a baseline to launch an app for 5 seconds, and if you run the test, the consecutive test, and if next time the app takes 6 seconds, your performance test will break. And you can debug the performance issues when the performance test breaks. So it's a good practice to write a performance test and run it on nightly basis because it's a heavy job and it has to run the test 10 times. So better it's keep it on nightly basis. So Xcode schemes. So Xcode schemes are basically how you structure your apps code and the UI test code. So it's always better to create a separate scheme for UI testing, separate scheme for performance testing. Okay, so we got 10 minutes and we have to cover lots of stuff. So I will just rush it for this stubbing and mocking because these are kind of advanced level concepts in Swift. So Swift stubbing and mocking is harder because there's no framework like a Mockito in Java or some frameworks in other language. There's no such framework in Swift. So you have to write your mocks by hand. And it's harder for XCUITests because XCUITests run in a separate process. And the only communication you get from your main app to your XCUITest app or process is using launch argument or launch environment. And you have to write those launch argument and launch environment in your applications code. That means in your production code, you have to write these things if you want to communicate with XCUITest app. And there are some local networking things, so you can spin up your local web services and listen from the responses from there. So there are some libraries like Swifter, Embassy, SBT, UI Test Tunnel, or you can use any server-side Swift framework like Kitura or Perfect or Vapor. Or there's another library called Swift localhost where you can allow local networking. So you can keep your all API responses locally somewhere and listen it from there. And so stubbing, you can get it anyway by using integration test if you write integration test or the API test against your stub. So I would recommend keep your UI tests as real as possible. Keep it limited and keep it as a real. So if there's any API change, you will find straight away. You will find some flaky tests because API changes, but you at least come to know that what is changing. So it is a good idea to have a set of UI tests which runs against your real endpoints. so that you can keep track of like what's changing. And in terms of the CI server, you need to select Smart CI server, which can give you ability to set up your test infrastructure, build infrastructure. So usually we can't tend to use Jenkins everywhere, but there are so many options that you can choose. So depending on our project requirement, you can choose the CI server of your choice. Avoid third-party tools if possible. Third-party tools create lots of pain and dependency on getting those frameworks infrastructure. If you want to keep it native, that would be great. So don't build app twice. Usually, when you set up for app for Appium, you have to build it once for like a unit testing. You have to build separate app for the Appium. So with UI tests, some people do the same mistake like XCUITests. So you build it for unit testing. You again build it for XCUI testing. So use the feature from Xcode Build. So test without building. And do not write the flaky CI script as well. Do not write the flaky test, as well as do not write the flaky CI script. Otherwise, it will break the build with unnecessary reason. And if you're doing parallelization, so Xcode 10 has enabled the feature where you can parallelize your XCUI test, not only with different devices, but you can have a different clones of simulator, and the simulator will distribute the test accordingly within each process. So you need to select the right candidate for parallelization. Then dealing with the flakiness. So flakiness will be always there if you're doing UI testing, no matter which framework you use. So if you use XCUITest, and if you have any kind of flakiness, so flakiness comes from anywhere. Because UI tests are not unit tests. Unit tests, once you write it, it will pass forever unless your business logic changes. But UI tests are basically written at the instance of time when application is get developed. So flakiness can come from anywhere, literally not only from your test, but the environment, your PlayKey App Architecture. So if your app architecture is not proper, then if app is flaky, then how do we expect your test become solid? So you need to make sure that your app architecture is good as well in order to make UI test good. You need to control your test data and network, which is another factor that contributes to your flakiness. So this is one of the things I read from Angie Jones' blog. She wrote an awesome article on testing in CI. So how you make your testing effective in CI. This is not for XCUI test, but this is normal CI and testing. So your test code require maintenance, and there's no getting around it. So basically, you need to keep your test code, especially UI test code. You need to maintain it. You need to change it according to your latest state of the app, and you have to keep eye on what's changing and what is required to change in your test. Or if tests fail, then you probably find the bug, or you have to adjust your test with new requirements. So you can see some benefits of using XCUITest. XCUITest is native and faster than any other third-party tool. It increases the collaboration with your developers, easy to integrate with CI/CD, enhance accessibility. So if you make the accessibility compulsory, it will help not only writing your UI tests, but it will help the disabled people who can't see or who can't hear. So that will help them as well. And it's maintained by Apple, so you don't have to worry about any API changes. So if any API changes, then Apple will announce well in advance. So you don't have to worry about any third-party tools or something, or you don't have to wait until this feature embedded into your third-party tool. So you see the XCUITest is there, but some of your excuses I often hear why you're not using XCUITest. So one of them is, okay, we have made a decision to use X tool in the past, for example, Appium. and we invested heavily into it, and we can't go back, and we don't have budget to reinvent the wheel because it works for now. Another one is very common, like we want cross-platform solution. We want test written once, and that can execute on Android as well as iOS. So these are two different technologies. Different companies maintain these platforms. So you are trying to bridge the gap between two major companies by doing this cross-platform selection. And where you should find the engineers with Swift XCUITest skills, it's one of the kind of thing where there are no people there with that skill. So how do we hire those kind of people? Some people say, oh, it's still new, it has some bugs, so we probably look into that, but that's wrong. It's very stable. I've been using it for 3 years, and I have a solid experience with XCUITest. And another thing, so we have already a tool which works for now, and we will keep it as long as it works. But companies never see the hidden cost, like maintenance and what efforts and investment it takes to maintain those tools. Even though they become a vital element, it's kind of like you can't get rid of them, or you know this is not working, but you can't get rid of them. So basically that kind of situation. So recap. So if you're building a native app, you should definitely try and see XCUITest as an option. If you're building cross-platform apps, then choice is yours. So XCUITest increase collaboration between your app developers and QA engineer who writes automation. And that's it for my talk. Any questions, quick questions?
Does this allow you to just record?
Hi, I'm Jatinder Singh from Boston Scientific Corporation. My question is that does XCUITest allow you to switch between applications so that you know how your application is working? You want to test how your application is working in the phone with call coming in, message coming in, so you can interact with those applications. Does it allow you that?
Yes. Since Xcode 9 and iOS 10, XCUITest has a facility of multi-app testing, where if you want to testing one app, you can launch another app at any time if you know the bundle identifier of that app. So you can launch that app, and you can interact with that app like you interact with your normal app. So you can write multi-app test with XCUITest. So you can launch one app before the start of this test. In between, you can launch another app, do something, keep the application state in that particular state, and then you can test another app. You can switch between different apps as well. So keep another app in foreground, keep it in the background, so it allows you to do that kind of things as well. So yeah, if you need more information, I will talk to you later, but it is possible.
Hello, yep. Sorry guys, we're running behind on schedule.
Cool.
Thank you so much to Shashikant.
No problem.